All right. So guys, 5.1 is something that we call normal distributions and the standard there are normal distributions and the standard normal distribution, okay? All right, so it says in chapter 4, we discussed discrete and continuous random variables. In 4.2 and 4.3, we worked with discrete probability distributions like binomial, geometric, and Poisson. So chapter 5, guys, we're going to talk about something called continuous random variables, okay? So notice what it says here. It says, recall that a continuous random variable can take on an infinite number of possible values, and continuous probability distributions are created to reflect the possibilities. And it says the most important distribution is what we call the normal distribution. Okay, so let me see if I can zoom down a little bit. Like that, and bring it back a little bit this way. Here we go. Okay, so guys, it says the normal distribution is a continuous probability distribution for a random variable x. It says the graph of a normal distribution is called the normal curve. Normal distribution has these properties. Okay, so the mean, median, and mode are equal. The normal curve is bell-shaped and symmetric about the mean. So guys, one thing I want to point out here, let me see if I can zoom in just a little bit. Here, whoa, I don't know what else does that. Come back up, here we go. And, okay, so one thing I want to mention, guys, is that, here. Okay, this right here, guys, remember what that symbol is? That's our mean, right? Okay. It says the total area under the curve is equal to 1. So the area, everything in blue here, guys, if we were to find the area of that curve, it's always going to be equal to 1. The normal curve approaches but never touches the x-axis as it extends further away from the mean. So as we keep going, this graph keeps getting closer and closer and closer to the x-axis, but it never actually touches it, both to the left and to the right, okay? And then it says between mu minus, anybody remember what this little, we were calling it O with a hat, but anybody remember what it's actually called? It's called the standard deviation, but anybody know what the symbol is called? Sigma, right? Okay, so this is our sigma, which is the same thing as our standard deviation, right? Okay, so it says the area between the mean minus the standard deviation and the mean plus the standard deviation of the curve, the graph curves downward. So what I want you to notice here is that the way the graph is shaped right here, it's curving downward. It's curving down like that. And then from the other point, from here further out, the graph is actually curving upward, okay? These points right here where it changes, those are what we call inflection points, okay? So we're going to figure out a couple of things dealing with this graph. Let me kind of scroll down a little bit here. It says discrete probability distributions are graphed with histograms. However, continuous probability distributions are graphed with a probability density function where the total area under the curve is 1. Okay, so let's take a look. Scroll down some more. So it says a normal distribution can have a mean and any positive standard deviation. These two parameters are actually what shapes the distribution. The mean gives the location of the line of symmetry. Guys, all we mean by the line of symmetry is that where the mean is right here, this graph is cut in half, right? That's what we mean by symmetry, okay? And the standard deviation describes the spread of the data. So let's take a look at the next part right here, okay? So it says match the normal curve with its parameters, okay? So remember, guys, quick question. Do you remember what this letter stands for again? That stands for the mean, okay? Guys, the mean is going to be the number that's right in the middle of the graph, okay? So let me ask you a question. If we were to look, say, at the first one, this one right here, what would you guesstimate that number right there to be? Good. So we would say the mean's going to be about 3.5, right? Now, we want to find the standard deviation. So guys, the next thing I'm going to do is I'm going to come over here. And remember where that inflection point is? If I were to go straight down, the distance between this point here and this number here, that's going to be my sigma. That's going to be my standard deviation. So what number did we end up with right here? 5. So we're going to say, look, let's take 5 and let's subtract off the mean. So what's 5 minus 3.5? 1.5, right? Good. So guys, Fred says that in this case, our sigma is 1.5, and we already said that our mean was 3.5, right? Okay, so I'm going to look here. Look at parts D, E, and F. This graph here would match up with which one? F, right? Wouldn't it match up with F? Because didn't we say that our mean was 3.5 and our sigma was 1.5? Okay, so this graph here is going to go with F, all right? Now, let's do the same thing here. So I'm going to come back to the next problem, and let's see if we can find the mean here. What's the mean here? 3.5 again, right? So here, our mean is going to be 3.5, okay? Now, we want to see if we can find what the standard deviation is. So guys, I'm going to try to be as careful as I can, okay? As careful as I can, and I'm going to go straight down. It's kind of hard to go straight down. All right, but 4 point something, right? So let's do it this way. Let's say, suppose we were to say it's 4.5, right? If we were to say it's 4.5, remember the way we're going to find our sigma? We're going to take 4.5 minus what number? 3.5. Wouldn't that give us 1? Okay, do we have another one of these DEF that also has a mean of 3.5 and a standard deviation something close to 1? D, right? Okay, so D. So maybe it wasn't really 4.5. Maybe it was something closer to like 4.2 or something like that, right? But do you see how we can kind of guess which one's going to be? So here we're going to say this one is D. Okay, now guys, let me ask you a question. For the first 2 graphs that we did, what was the mean of the first graph? 3.5. What was the mean of the second graph? 3.5. Okay, so let me ask you a question. Does the height affect the mean? No, the height does not affect the mean. Okay, let me ask you another question. Which one of those graphs was a little more wider? The first one, right? Wasn't F wider? Okay, now, we know F is a wider graph, okay? Which one had a bigger standard deviation? F, right? So guys, the bigger my standard deviation, the wider my graph is going to be, right? The standard deviation is telling you, on average, from the mean, most of the data should fall within 1 standard deviation to the left or to the right, right? Now remember what we mean by 1 standard deviation. So like if the average of a set of numbers was, say, 77, and the standard deviation happened to be the number 3, 77 would be my mean, and then 1 number to the right would have been 80, because I'm adding 3, and 1 number to the left would have been 70, what? If I'm taking 77 minus 3? 74, right? Okay, let's think about another set of data. The average is 77, but the standard deviation is 10. If I go 77 plus 10, what number am I at now? 87, right? If I take 77 minus 10, what number am I at now? 67. So didn't our graph just get wider, right, by doing that? Okay. So now, by process of elimination, what do you think C is going to be? E. It has to be, right? So let's just double check to make sure it is, right? If we were to figure out what's our mean, we come down here, it's about what number? If it's right in the middle between 1 and 2? 1.5, right? And then again, guys, I'm going to try to be as cautious as I can or direct as I can. Oh, that looks like it's about 2.5. And if we were to take 2.5 minus 1.5, we'd get 1. Oh, maybe it's not exactly 2.5. It's a little smaller. But our standard deviation here is 0.7. So this one here is going to match up with E. Does that make sense? Good. Alrighty. It's probably going to throw me all over the place, but I want to zoom in a little bit more. And let me see if I can go back and find it. Whoa. Not that part. Here we go. Okay, and now I zoomed in too much.
The bigger the standard deviation, the more narrow the graph will be.
Well, let's come back. Which one had a bigger standard deviation? The first one. Okay, so was the graph more narrow or was the graph less narrow in the first one? It was wider in the first one, right? So which one looks more narrow? So guys, come back over here. If we were to look at this graph here and look at this graph here, which one looks wider? F. F looks wider, doesn't it? And doesn't F, we said our standard deviation was what number? 1.5. So the more wide, my graph's going to have a bigger what? A bigger deviation, right? More narrow, right? Tall, slender, my graph's going to have a smaller deviation, right? More wide, bigger standard deviation, right? Okay, good question. So now let's take a look over here. See if I can bring this down a little bit. There we go. Okay, so let's take a look at the next question. Okay, so number 2 says, which normal curve has the greater mean? So a little while ago, I asked you, did the height have anything to do with our mean? It didn't, right? Okay, so remember what the mean is here, guys. The mean is going to be the number right where down the middle, right? So what number would you sort of guess to be right there? About 45, right? This one here looks like it's going to be about 45, okay? What do you say this one would be? That one's going to be 60. Okay, so which curve has the greater mean? A, B, or C? B does, right? Okay. Now, which curve has the greatest standard deviation? That means the difference from the mean to that inflection point is going to, so that means my graph's going to be which way? Wider. Which graph is more wide? C, there we go. You see what we mean? Whack, whack. All right. Which two curves have the same mean? A and C, right? They have the same mean, okay? And what's the mean for B? We already circled it. 60, right? Good. All righty. So now let's go ahead and scroll back down a little bit and see if we can figure out the next part. Okay, so let me move this over un poquito. All right, so number 3 says, what is the mean weight and standard deviation for all new newborns in the U.S. in a recent year? Okay, so guys, we're going to kind of scroll down here. What's our mean going to be? 3,300, right? 3,300, okay? Now, remember the next part we need to figure out. We need to figure out what's our standard deviation. So guys, right about here is where that curve starts to change from going down to kind of curving back up. So if I were to kind of trying to go as straight as I can. Well, take a look. Here's 39, right? So I'm a little higher than 39, but I'm smaller than what number? 4,500? So I'll tell you what. Suppose we said it's going to be right between those two numbers. Do you remember what happened to my other? We add them and divide by 2. Okay, guys, so let me see if I can get my calculator up here and running. Yes, I always want it to run. Okay, so we said we're going to add them together and divide by 2. So what numbers are we adding together again? Let me move this calculator out of the way. 39 and 45? So let's go 3,900 plus 4,500 and equals, and then we're going to take that number and we're going to divide it by 2. Looks like about 4,200, right? Okay, so remember, that's not telling me my standard deviation. The way I'm going to find my standard deviation is I'm going to take that number 4,200 and we're going to subtract it from 3,300. Okay, isn't that about 900, right? That's our standard deviation. So guys, all it's telling me is that the distance from here to here is 900. And the distance from here to here is 900 also, right? Does that make sense? We're good so far? Que bueno. All right, let's keep going down then. Okay, so it says the scale tests for the New York State Grade English test are normally distributed. Excuse me, estimate the mean test score and the standard deviation. Okay, so I'm going to come back over here. I'm going to grab my pen, and we're going to come straight down here. I'm trying to come as straight as possible. Okay, guys, let me ask you a question. This is 620, right? What number would this one be? 630, 640. This one would be 650. This is 6600, or I'm sorry, 6060. Couldn't we say this number here, I don't know, 655? That seem good? Okay, so let's go like this, 655, right? Okay, and okay, so guys, I'm going to try to find roughly where the curve changes. It looks like it's right about here. Okay, so let's take, good question. So what I want you to look at is, do you see right here how the curve, which way is the shape, sorry, the curve is going which way? Down, right? And then do you see right here, now which way is the curve going? Do you see how, like, the first part, it goes like this? And then do you see how the second part, it kind of does that number? Does that make sense?
So just maybe the middle of it.
That's right. So it should be somewhere right about here, right? There's gonna be a point, guys. But so really what you're trying to find is you're trying to find where on the graph. So do me a favor, look at the left side of our graph. Okay? So if I look over here, do you see how the curve is going down like this, right? Does that make sense? Like, isn't the curve kind of doing this number? It's going down like that? Yeah, like if you're on a hill and you're going down, right? And then, doesn't it look here like it's going like that? So do you see how this is kind of like a frown? Like half a frown? Like, think about it this way. That's a frown, right? And then, so guys, sometimes we say, when it's down like this, it looks like a frown. And then when it's going up like this, I've already kind of keep doing that, but do this number, it looks like a cup. Somebody said that a long time ago, and I never forgot it. But let me try to erase, kind of give you an idea. What I'm trying to figure out is where does the graph change sort of the curve? It's going down, and then it's going up, in the sense that the curve changes, right? This is downward, this is upward. So think about it. You can see my hand, right? This is down, this is kind of up. Does that make any sense? Right? Okay, so there you go, right? Okay, so guys, if we said this number was 655 and where it changes is at 680, how would I find my standard deviation? Subtract, right? We're going to take 680, we're going to subtract 655. Anybody know what number that is? 25, there we go. Okay. So we got our standard deviation, right? Okay. Okay, I'm going to keep scrolling down over here. All right, let's take a look at the next problem. It says, what's the mean of the curve? Estimate the standard deviation. Okay, so let me come back. Let me grab a pen. Come back to black. Okay. So guys, what do you say our mean would be? 52. Okay. All right. So again, guys, I'm basically looking right about there, right? So 64. So we're going to say we're going to take 64, oops. We're going to take 64 minus what, 52? And we're coming up with 12? There you go. Okay. All right. So guys, let me keep scrolling down. And let's see if we can do the next part here. So guys, we have something called the standard normal distribution. So it says, the reality is that there are infinitely many normal distributions to represent the infinitely many situations with infinitely many means and standard deviations. So the normal distribution with a mean of 0 and a standard deviation of 1 is something that we call the standard normal distribution. Do y'all remember in class that day when I brought you all a handout and there was a couple of problems where we had to find like the mean, and then we were finding, and it gave us like the standard deviation, and then we're trying to say what percent of the women are between this height. I don't even remember the exact problem that we did. Let me see if I can pull it up, because I know we went over it. Let me see if I can find it here. It was something called, what, here we go. Okay, so do you remember when we did this problem here? Okay, here we go, blood pressure. And we said, okay, like what percent of 18-year-old women in this group have a systolic blood pressure between 96 and 120? Do you remember doing this in class one day, guys? A couple of weeks back, right? And then we looked at the same thing for like college GPAs. We did this like right before we took the first test. And then we did the same kind of thing. We were finding the Z-scores. So we did this a few weeks back. The idea here, guys, is in this problem, we're going to be looking at that sort of Z-score idea, where the mean is always going to be interpreted as, what's the number here in the middle? 0. This is 1 standard deviation away. This is 2 standard deviations. And because I'm going to the right, I'm 1 standard deviation above. Or going this way, I'm going 1 standard deviation below, right? Because I'm going in the left direction. Okay, so it says right here, recall that a Z-score for a random variable x is a position that indicates the number of standard deviation. The value lies from the mean. The Z-score can be computed, and there's a little formula right there. Okay, so we're going to find, just to kind of give you a heads up where I'm reading, we'll now examine finding the area in the curve for all values of the random variable x using the standard normal distribution under the standard normal curve to any left score of negative 3.49 to positive 3.49. Okay, so I want to say this is on the bottom of your notes here. So it says the cumulative area close to 0 for z-scores, is close to 0 for z-scores close to negative 3.49. So look, this is negative 1, negative 2, negative 3. Negative 3.49 would be a little further to the left, right? So it's saying the area. So guys, we're talking about the total area here, everything in blue. The total area is going to be 1. But if you're trying to figure out what's the area over here, we're going to say that number is going to be close to what? Close to, well, what's the area here? So think about it this way. If I wanted to figure out how much space is right there between that x-axis and where the curve is there a lot of space or is there a little bit of space? Very, very little. That's why we're saying the space is going to be what number? 0, right? The area is going to be equal to 0, okay? So now we're saying the cumulative area increases as the z-scores increase. So guys, as I start going this way to the right, and I start taking slices, like I'm going to look at the area here. If I take another slice, now I'm going to look at all that area. And I take another slice, now I'm going to look at all that area. All we're saying is that the area is going to keep getting bigger and bigger because we're looking at more parts of the curve. And then again, if we want to look at, say, the area right about there, just from this little piece, it's also going to be close to what number? 0, right? Close to 1, because we're actually looking at everything. We're looking at close to 1, so we're looking at all this thing here. Alrighty, so let me scroll down to the next page. Okay, so the other day in class, people were like, oh, do y'all remember, guys, we did a problem last week where we were trying to find one of the probabilities and we used the table, and somebody said, can't we always use the table? We're going to be able to use the table today. So guys, I did pass out this table here for y'all. So I want you to do me a favor. Grab the table, okay? And it says, look, we're going to find the cumulative area that corresponds to a z-score of negative 1.25. Okay, so I want you to notice something here. My z-score right here is what number? 0. Here it's negative 1, here it's negative 2. Negative 1.25, guys, would be somewhere right about here. And in essence, what we're doing is we're trying to figure out what's the area to the left of that number, okay? So what we're going to do is we're going to look at our table. I think I have it right here. And we're looking at negative 1.25, right? Okay, so guys, I want you to notice something. Here is negative 1.2, And do you see how we have that little 0.5 right there at the top? So what I'm going to do is I'm going to try to find where those two pieces would meet. Y'all agree they would meet right about here? 10.56, does that make sense? Because we're looking at a negative 1.25. Am I doing okay so far? Okay, so look at the little handout that I gave you, the little formula, the little table, right? So guys, just to give you a heads up what I'm doing, wrong one, sorry. This one here, I'm going to zoom in a whole lot so we can see it. And let it focus. Okay, so do you see right here that's negative 1.2? Okay, so I'm going to start moving to the right until I get to negative 1.25, and that would be this one right here, isn't it?
So if you were looking for negative 1.22,
We would continue until we get to that O2 part, right? So think about it this way. Here's the number to the left of the decimal. Here's the first one to the right. And then the numbers over here. Do you notice how the first number is 0? So it's really saying, look, the first number is only going to be a 2. That number is going to be a 5. So negative 1.25. And so in essence, aren't we looking at that number right there? The 10.56? Fred, are we good? Are you okay on how I'm coming up with these numbers? Are you okay how I came up with the negative 1.25? Looking at my chart.
The 1.28, we go to the second column?
That's right. So if we wanted to go to negative 1.28, we would say, look, let's use that one and that one right there. Better? Good, good. Okay, so guys, what number did we come up with? Okay, so here's my answer. 0.1056. Does that make sense? Using the table? Okay, so guys, let's get a little practice using the table, okay? So look, we're going to scroll a little mouse. Okay, look at the next one here. It says, find a cumulative area that corresponds to a z-score of 2.15. Okay, so guys, I want you to notice something. Remember, the whole area under all of this curve is always going to be equal to what number? It's always going to be equal to 1, right? So think about it this way. If I were to ask you, what would the area be to the left of 0? What do you say the area to the left of 0 would be? 0.5, right? Because the whole thing is going to be 1. We're looking at actually 2.15. So now what I'm really trying to figure out is what's the area all of this? So number one, everybody agrees it's going to be more than 0.5? Because we're already going more than half the graph, right? So guys, I'm going to come back to my table, right? Okay, and I'm going to see, do we find a positive 2? So I think if you look at the next page, do you see the other page of it? Okay, and we said we're looking for what number? 2.15. So look, here's 2.1, and here is my 0.5. So what number are we coming up with? 0.9842, guys. So all I'm going to do is I'm going to come back over here, and we're going to say our area is going to be 0.9842. Okay, so let's come back and let's see how I'm figuring out that, like, why am I coming up with that number? So look at the z-score I'm trying to find. 2.15, right? Okay, so look, I'm going to come back over here. Do you see how this is 2.1? And then that's a 0.5, that's telling me it's going to be 2.15. So look, if I were to say, suppose, that's right. Suppose I wanted to find 2.1, or it'll probably even write it this way. It'll probably even write it as just 2.1. Then you're going to say, well, look, then I want my other numbers to be what? 0. So 2.1 would have been 0.9821, right? If I want to go 2.11, I'm going to look at that one. Does that make sense? 2.12, look at that one. 13, 14, 15. Marisol, are we okay? So? Okay. So look, let's come back. Let's try another one just to make sure that we're good. Okay, so now, guys, I want you to notice something here. When we're finding the area, that table is always telling me the area to the left of my number, okay? It's always telling me the area to my left of my number. So now, I want you to look here. We're going to find the area to the what? To the right of negative 1.05, okay? So look, first off, negative 1.05. Do y'all agree that's going to be somewhere right about here? Negative 1.05. It's going to be to the left of the number negative 1. Okay. So what we're trying to do, guys, we're trying to find the area actually to the what? To the right. Okay. Because it says we're going to find the area to the right. Okay. I know we said this earlier, but I want to make sure that everybody's good. So when we have our graph that looks something like this, I know that looks pretty horrible, and we're going to find the area inside all of it, inside all the area here. What is the area always equal to? It's always equal to 1. Okay, so if we want to find the area to the right of this number, let's use our table to find the area to the left, and then to find the red area, we can say, let's do 1 minus whatever we get. Does that make sense? Okay, so let's come back over here. We're going to look for negative 1.05. So guys, I'm going to go back to my table. It's probably going to be on the other page because it's the negative. And we said negative 1.0 what? Negative 1.05. Okay, so let me erase this business here. Okay, so negative 1.05. So guys, look, first I'm going to go negative 1.0. And then I'm going to go to the 5, which should be this one right here. So 0.1469, right? Okay, so I know that the area right here is 0.1469. How would I find the area over here? Yeah, we're going to go 1 minus 0.1469. So 0.8531. There you go. You just got to make sure you look at the question. So the table, guys, the table here, always tells me the area which way? To the left. So if I ever need to find the area to the right, I can find the area to the left and then just do 1 minus that. Does that make sense? Good. Okay. So let's take a look-see. Let's come back to the next part. I'm going to keep scrolling. Okay. All right. So again, look what it tells me to do here. It tells me when to find the area to the what? To the right of 2.50. So guys, y'all agree that 2.50 is going to be this piece right here? Okay, look at that area. Does that area look like it's a lot? So the number should be kind of close to what number? Kind of close to 0, right? So what we're going to do is we're going to say, well, look, let's find the area to the left, and then to find the area to the right, we can just do 1 minus, right? So we're going to come back to our table. Okay. We want to find positive 2.50. Okay. So here we go, positive 2.50. So guys, I want you to see where the positive 2.50 is. Oops. Okay, there we go. What number does it look like we're coming up with? 9938? Okay. So far, are we good? Marisol, are we doing okay now? Better. Good, good. Okay, so I'm going to come back over here. And we said we're going to take this area here was 0.9938. And then, so then we're going to say to find our area, we're going to do 1 minus 0.9938. And guys, are you coming up with 0062? There you go. And didn't we say that number was going to be kind of close to what number? Kind of close to 0, right? Because look at that red area. Look how small it is, right? Okay. All right. So now let's take a look at number 10. Number 10 says find the area under the standard normal curve between negative 1.25 and 0.65. Alrighty, so let me come back here, grab my pen. Negative 1.25. So negative 1.25 is going to be somewhere right here. Negative 1.25. And the other one is a positive 0. What? 65. So somewhere right here. And we're actually trying to find the area where? In between. So we're trying to find this area, right? So let me ask you a question. Anybody have an idea of what we could do? Uh-huh. Find both. Okay, so guys, look, if we were to do this, if we were to find the first one, remember, that's going to give me the area which way? To the left. Okay, so let's come back and negative 1.25. So I'm going to try to see if we can find that number. Let's see, negative 1 point. So remember, we're going to, was that the number, right? Yeah, it's because it's negative 1.25. That's right. So we're going to come back over here, negative 1.25, 1056, right? Isaac, are we okay?
Yeah, I was looking at 11.
Okay. So we're going to say the area right here, guys, is 0.1056. Okay. I'm going to switch back. I'm going to go back to my red pen right here. Guys, when we do this on using our table, and we do the 0.65, isn't that really telling me the area of everything that way? Okay. So if we come back to our table, we're looking for what number now? 0.65? Positive 0.65, okay. So, okay, positive 0.65. Does it look like it's this number right here? 0.7422? Okay. All right, so the area in all of the red is what do we say, 7422? Okay, so now if all we really want to find, guys, is the middle, what are we going to do with those numbers? Subtract them, right? We're going to take 0.7422 and we're going to subtract 0.1056. And anybody got a calculator know what you come up with? 0.63? 66. There we go. Okay, so guys, one of the reasons why I was showing you the table is because sometimes I think we get a little too like, man, with a calculator, how do I do this again? How do I do this again? How do I do this again, right? There's so many times that we're using the calculator. And so sometimes to me, using the table, it's a little more old school, but I think we've all used the table at some point in our lives, right? We can kind of figure things out. Not that we cannot use a calculator. We can use a calculator, okay? So all I'm going to do, guys, before I go on to the next problem, is I'm going to come back and I want to check our answers for, say, this one right here. And I want to see if we use the calculator, would we come up with the same answer? So guys, do me a favor, grab your calculator, right? Turn it on, obviously. And remember, we're finding the area, for number 6, we're finding the area to the left of what number again? For number 6, when we found the area to the left, what was our Z number they gave us? Negative 1.25, right? Okay. So guys, on your calculator, the way you're going to do this, you're going to go second again, second vars, okay? Do you see how number 2 says normal CDF? Remember what CDF means? We're accumulating everything, right? So we're going to go to normal CDF. Okay. All right. Since we're going all the way to the left, what you can do, you can type in a number like, say, negative, sorry. You can type in something like negative, I don't know, 99999, because we're trying to go all the way to the left. And then where we're going to stop at, what's the last number we're going to stop at? Negative what? Negative 1.25, right? So guys, you're going to put a comma and then negative 1.25. Okay, close out the parentheses. And if I hit enter, are we coming up with 0.1056? There you go. On what other calculator? Okay. All right, so let's take a look, see. We'll see. So look, let's see. I think this one will do it the same way. Let me double check. Turn it on. Bars, another CDF. Okay. So your question is, how do I do it? How do I do it here, right? Like this? Yeah. Okay. So remember, what was the on the other calculator, guys? What was the first number I typed in here? Negative what? a whole bunch of nines, right? Okay, so I'm gonna do the same thing here. My negative 99999. Okay. My upper, what was the last number we stopped at? Negative what number? 1.25. Guys, the mu is going to be 0 because remember, in the standard normal distribution, the mean is 0, right? The standard deviations are going up by 1. We're either going up 1 and 1 and 1 positive or 1 and 1 negative. So those numbers will stay the same. Just scroll down, hit enter again. And didn't we still get 0.1056? There you go. Yeah? So let's go like this. Second vars, right? We're going to go to normal CDF. Okay, enter. So remember, I want you to think about the picture. So, let me move this calculator out of the way. So think about the picture for a minute. Come back on. There we go. Think about the picture for a minute. We're gonna go from all the way over here. How far? As far as we can possibly imagine. What number are we gonna stop at? What was our z-score here? I know I just covered up the calculator. Negative 1.25, right? So when I do this on my 84 or whatever calculator you have, your lower bound, because we were going all the way to the left, I'm going to type in negative and a whole bunch of nines. Why? Because I'm trying to go as far to the left as I can go. Does that make sense? Now my upper bound, where am I going to stop at? Negative what? 1.25, right? Guys, remember, my mu is going to be 0 because we're talking about the standard, the z-score. Remember, the number in the middle was 0? And then each of those things goes up by 1 or 2 or 3, either to the right or to the left. So here, you're just going to type in those numbers, hit paste, hit enter. It should pop up that right there. Hit enter again. And I'm going to ask you a question. What number, if you go to 4 decimal places, what number did you end up with here? 0.1056. And if we look, what number did we end up with there? 0.1056, right? My point is here, guys, you have options. If you want to use the calculator, you can use the calculator. If you feel more comfortable with the what? With the chart, you can use the chart, right? If you want to try using both to double check your answers, you can use both, right? But we should be coming up with the same numbers. That's right. So look, we'll do another one like that. Look, let's do this one here. Say to the right. We were doing this one here. We're finding the area to the right of what number? Negative 1 point what? 1.05. Okay. So guys, I'm going to pull up my calculator again if I can get it. Here we go. Okay, so since we want to go to the right of negative 1.05, guys, we're going to start here at negative 1.05. We're going to go all the way for how long? Infinite, right? So look, I'm going to do the same thing. I'm going to go second vars. Okay, I'm going to go to normal CDF. Okay, what number am I starting off at though? Okay, so my lower bound is going to be negative 1.05, right? Comma, where am I going to keep going? All the way to what? Yeah, all the way like to infinity and beyond, right? So I'm going to go to 99999 like that.
Positive, right? Positive,
because we're going in the positive direction, right? And then I'm going to close off my parentheses. I'm going to hit enter. And are we coming up with 0.8531? There you go. Okay. So guys, again, those of you who want to do it on the calculator, right? Second vars. We're going to go to normal CDF. We are starting here at a negative 1.05. Since we're going to the right, we're going to go to the right forever, right? And then hit enter again, and we're coming up with 0.8531, right?
The left and the right hemisphere, whatever you want to call it,
Boundaries?
will always be negative to the left.
Positive to the right, right? So think about the number line. Isn't like if here's 0, aren't the positive numbers to the right, the negative numbers to the left?
As long as the wording says left, you're negative or right.
And if it doesn't say, remember, if it tells you, so like I want you to look at the one we just did right now, number 6, right? It just says, find the area that corresponds to a z-score of what? Negative 1.20, I'm sorry. This one right here, it says find the cumulative area that corresponds to a z-score of what? Negative 1.25, right? Guys, if I look at my my chart here. So look at my chart. It's always telling me the area to the what? To the left, right? Because that's the area that's shaded, right? So when I'm using this table and, this table is always going to give me the area to the left, right? It's always going to give me the area to the left, okay? So look, guys, I want us to come back. I want us to check one more with the calculator again, okay? So look, let's check, let's see. Right, these are cumulative, right? Because we're finding the area all in between, right? Okay, so guys, let me ask you a question. Look at this one here. We came up with our answer as what, 0.6366? Okay, if I'm gonna do this using my calculator, right? I'm gonna come back over here, I'm gonna go second vars, I'm gonna go to normal CDF and hit enter. What's my lower boundary gonna be? Very good, negative 1.25, okay, comma, what's my upper boundary gonna be? 0.65, okay, and we're gonna close it off, and we should be coming up with what number? 66, it should be. We came up with 65, so maybe we did a little round off error or something like that, right? But let me ask you a question, are we pretty close? Yeah, we're pretty close, right? So, again, guys, just to show you one more time on this calculator here, again, depending on the way yours looks, normal CDF. So again, I'm just gonna switch back real quick so we can see our lower boundary was negative 1.25, our upper boundary was 0.65. So my lower boundary was negative 1.25, we said. And then this one was a positive 0.65. And enter one more time. Oh, what did I do? Hit something there. Put too many commas. There we go. 0.6365. That's the same thing we got, right? Okay, so let me ask you a question. Who feels more comfortable with the table? Okay, so guys, those of you who feel more comfortable with the table, use it, right? Let me ask you a question. So now, as everybody who raised their hand, don't raise your hand this time. Who feels more comfortable with the calculator? Okay, so again, everybody's different, right? Let me ask you a question. Is one way right or wrong, or are they both right? They're both right. You're going to find the way that you like, and that's the one that you're going to use, right? All right, cool. All right, so guys, let's switch off so we can finish up this business here. Oops. Oh man, what happened? Where did we go? There we go. Okay, we'll figure it out a little bit. Okay, so guys, I'm going to ask you to do me a favor. Do this one here. Remember, and I'll give you a heads up. If you're doing it with the table, you're going to do it like the way we did that one, right? And if you're going to do it like the way we did the calculator, you already know what your lower bounds and upper bounds are going to be, right? Okay. I was talking with some of the, hold on, I'm going to pause this part real quick. Here we go, go down, here we go. More than welcome to use the calculator, okay? So it should be recording again. Let me double check to make sure that it is. Yeah, we're good. Okay, so look what we're doing here, guys. We are finding the area between what two numbers? Negative 1.5 and positive 1.5, right? Okay, so y'all agree this right here is going to be negative 1.5? Okay, guys, didn't we say that this graph is symmetric in the idea that if we draw a line right through the middle, that cuts the graph in what? In half. Okay. So if we're trying to find the area between negative 1.5 and positive 1.5, in essence, what we're trying to do, we're trying to find this bit in the middle, right? Okay. So, guys, if we were going to do this, wouldn't we really say, we know the whole area, yeah. The total is gonna be 1, right? Okay, did anybody using a table figure out the area in the red? And that to the left of negative 1.5? 0.00, I'm sorry. Uh-huh. So 1 0 or 2 zeros? Okay, 1 0. So 0.0668, like this? Okay, guys, let me ask you a question. If this area in the red right here, if that area is 0.0668, do you think this area is also going to be 0.0668? Yes, it is, right? So couldn't we say, look, let's take those two numbers and add them together, or let's take those two numbers and multiply them by how much? By 2? Do me a favor, anybody got a calculator? What's 0.0668 times 2? 0.13 something other? 0.1336? Okay. And then guys, if we know the total area is 1, wouldn't we say we're going to take 1 minus this number here? And wouldn't that tell me the area that's still left in the green? Does that make sense?
Sir,
Yes, ma'am.
how did you get the 0.0668?
So I had asked somebody, I said, did anybody use their table, right? Did anybody go to the table here and go to the negative 1.5? That's right. So we're looking at, see, here's the negative 1.5. And do you see how this is the 0, 0? So we're looking at that number right there, right? Does that make sense using the table? Victor, am I okay? No? Did I lose you?
The positive, it's not the same as.
No, because remember, the table is always telling me the area to which way? To the left. So if I go to positive 1.50, that's going to tell me all of that area. You understand my point? That's why I'm doing it this way, right? And then, guys, if we switch back over, and we were able to find it, and so I'm sorry, what number did we come up with when we took 1 minus 0.1366? That's okay. I want to say it's going to be like 86, 4, right? And there you go. And guys, just to give you a heads up, if you use your calculator, right, you turn it on, and you go second, bars, normal CDF, what two numbers are we going to put in? Negative 1.5, comma, 1.5, close it off. We should be coming up with 0.8664. Hey, there we go. If we round that 3 to a 4, we're going to be good, aren't we? There you go. There you go, right? So again, that's right. So again, what I wanted to do, guys, is I wanted to give you guys the opportunity to use both. And then you can decide which way works better for me, right? If this works better for me, if you are married to the table, I want you to use that, okay? Because this is what you feel comfortable with. If you're more comfortable with a calculator, then that's what I want you to use. And then I also want you to, like what Fred said, hey, well, you know what? Sometimes I might like using the table, but for a problem like this, man, the calculator is super easy, okay?
Depending on the wording, the problem, or, however your information is distributed.
That's right. Okay, so guys, look, let's do this. Let's go ahead and do the next problem here. It says in the next section, we're going to learn how to find the area under the curve for a given value of z is actually the probability that z is less than the z-score. For example, the area to the left of z equals negative 0.99 is 0.1611. That means that the probability of z less than negative 0.99 is 0.1611. So transforming non-standard normal distributions to z-scores will help determine probabilities in certain events. All right, so it says, look, refer back to problem number 4. So I'm going to go back to my notes, guys. I want to take a look at problem number 4, wherever we is, if I can find it. A little bit higher. Here we go. So problem number 4, what did we say our mean was here?
655.
And our standard deviation? 25. Okay, so guys, what I'm going to do, I'm going to come back over here, I can finish. Here we go.
So this type of curve is like the first one.
That's right.
Okay.
That's right. Okay, so look what we got here. It says, so in the first problem, guys, we said that our mu was 655 and our standard deviation was the number 25, right? Okay, so it says, what's the probability that a student chosen at random scored less than a 640? Okay, so remember, when we looked at our graph here, trying to make this as pretty as possible, that was our 655. We're looking for the probability that a student scored less than what number? What number? 640, right? Isn't that number right there? Okay, so we're looking for the area, guys. We're looking for the area under this curve. What we can do is we can say, look, instead of using those numbers, because we don't know what the area is going to be, let's compute it to a z-score. So guys, I want to say that here in my notes, let me see if I can scroll back up a little bit. There we had a formula for z-scores somewhere. Here we go. Do you see that formula right there where it says z equals x minus mu divided by sigma? Okay, so what I'm going to do, guys, I'm going to come back over here, and I'm just going to copy down that formula. So z is equal to x minus mu divided by sigma. Okay, the x is the number that they're giving me here, which is what number? 640. So I'm going to take 640. We're going to subtract off our mu. We said our mu, or mean, was what number? 655. All that's going to be divided by what number? 25. Okay, so guys, just to make sure when you're doing this on your calculator, make sure you do the subtraction first. So go 640 minus 655. Oops. Is that a negative 15? And then we're going to divide that number by what? 25, okay. So I'm coming up with negative 0.6 or 0.6, right? Negative 0.6, same thing as 0.6, right? Okay, so what we're going to do now, guys, in essence, what we're doing is we're transferring this to a z-score, and we're transferring this to the idea of either using our table or our calculator so we can kind of figure out what's going on here. So think about what negative 0.6 would be. It's going to be a little bit, not exactly in the middle, but yeah, a little bit more to the left, and we're finding this area right here. Okay. So, guys, those of you who like the table, what you're going to do is you're going to say, okay, let's use our table, and let's go to negative 0.6. So if I use my table, and I'm just going to kind of look at it here on the one that I actually have, point 2743. Okay. Does that make sense? So negative, yeah, isn't it 0.2743? Right? Okay, so that is the area to the left, right? Now, guys, if you wanted to use your calculator, remember, we're finding the area to the which way? To the left. So remember, we're going over here forever and ever and ever and ever and ever. So I'm going to go normal, or second vars, I'm sorry, normal CDF. Since I'm going to the left forever, negative a whole bunch of nines, okay, comma, negative 0.6 or 0.6, however you want to write it, okay, close it off, hit enter, and are we coming up with the same number? 0.2743, right? There you go, and you got it. What do you think? Does this stuff make sense? We're doing okay? Okay, so guys, let me